thanks for joining us. Thanks for joining our friends F5, and I meant to say Red Hat. I'm not sure if maybe Red Hat is here, but thanks for joining us. We're going to run through a little bit of content, about 306 slides, and a quick 30-second demo at the end, and then we'll be good to go. I think we've got 4 use cases that we're going to go through some demos on, so we're going to keep this pretty demo heavy. Just to do a little bit of introductions, if you haven't been to an Arctic event, interrupt us, throw a hand up, throw a beer at us, hopefully throw a beer at us. Interrupt at any point in time. The whole point is to be interactive, so if you have questions, let us know. We can dive deep and go into a different topic if we need to. All the demos that we've built, we've pre-recorded because we don't trust the demo gods. They've burned us before, and so we've pre-recorded them. We'll run through them and literally just did them this morning, but the idea is the lab environment is all on itself. So if you want to dive into something a little bit further, fire the laptop and kind of go through something a little more depth. But yeah, we'll keep it kind of light on the content side, kind of level set a little bit, and then just kind of dive into use cases, run through some use cases that we built to demonstrate, and yeah, hopefully get some Q&A discussion and have some beers and snacks and all that good stuff. So. There we go. So for those that didn't notice, we actually really didn't have a great title, so we decided to throw every industry buzzword that we could think of that is hot at the moment into one title. The challenging part when we put the invite together, I don't think it was clear that we were joking about it. I think people maybe thought we were serious about this title, but maybe we should be. But either way, if we could throw one more buzzword into this, we could. I just couldn't think of another buzzword that we hadn't used yet. I think we used up.
Couldn't fit it on the slide either.
Couldn't fit it on there. Wanted to give you a bit of a high level of the agenda. So we're going to do a little bit of overview on some of the tech that we're going to showcase. Some of this is pretty new. I know AS3 for one is pretty. It's brand new, I think. We'll go through some of how it integrates into Git. So, kind of integrating that, F5 automation workflow into Git and kind of getting comfortable with how it works. And then go through a use case around DR, kind of where this fits in the world of, ephemeral builds of things and how that plays in an F5 world. And lastly, in case number 4, for those of you that are OpenShift familiar, or maybe those that aren't, we're going to do a demonstration of F5's native integration into the OpenShift stack, and kind of show you how to connect F5 from an application delivery perspective directly into microservices. And then Q&A. From a presentation standpoint, I love that picture.
I figured this was a theme.
Oh, man, I feel bad. My picture sucks now. Okay, well, so anyways, from a presentation standpoint, my name is Tim Farrell, or Dark Helmet, whichever one you choose. Call me by either one, I'm fine with it. From a technology focus standpoint, my prime focus is on automation, microservices. I would say I've got a healthy F5 background. More recently, over the last couple of years, I would say I'm getting back into F5, and it's kind of been interesting, kind of hitting the training wheels back off the bike. But yeah, so in terms of focus areas, that's kind of where I'm sitting. And then I have Hart Ripley with me as well, who is currently enjoying a beer. And I don't know if you want to do.
Yeah, so I focus a lot on the network security automation side, right? So infrastructure, that type of stuff, but automation in general, right? A lot of experience with, network devices in the past, doing it the traditional way. So now, going down the automation route, F5 is a big piece, right? Because it integrates into a lot of these environments that exist today. So taking it to the next level. Cool.
I think we'll kick it off to you.
Okay, so we're gonna get going here. The way we're gonna lay this out is we're gonna go through a bunch of the content and then we'll do the demos after, right? So why are we here? What are we looking to solve? With this automation, consistency, right? So everyone's been down the road of copying and pasting configs, storing configs all over the place, passwords, that type of stuff, right? So we're looking to find a common ground and store the stuff in a way that it's secured, it's consistent. If someone needs to get it, they know where it is, right? If someone needs to create a new one, they know where the templates are, that type of stuff, right? So And when we actually deploy or automate the deployment of this, we want it to look the same every time, right? So we need to know, did it work? If it didn't, we want to run it again, and we don't want to have to remove it beforehand, right? We want to just be able to consistently deliver it. Declarative intent. So a lot of the automation that was done in the early days, especially on the networking side, was more so issuing commands to devices, right? Oh, go run these commands on these devices. Well, you don't have a lot of control of if you have an error or something happen. Also, the main thing is, how do you remove the config? How do you know what's there? Validation, that type of stuff, right? So, especially on the application side, which we're going to talk a lot about today, we want to declare what we actually want on the device, right? The configuration, the way the device should be, right, as an end state. Instead of doing ad hoc commands, that type of stuff, we can define the entire configuration, push it down that way, and error mitigation. So that kind of goes under the consistency thing as well, right? We want to make sure that someone's not making a typo, right? We want an approval workflow, something along those lines where, like using Git or something like that, where we can have code commits, right? We can have checks, we can look at diffs, that type of stuff, and we have a role mechanism in there as well, right? So, access control. So, everyone has access to every device in a lot of cases, right? We want to scale that back and say, can we have a central way to control access to a switch, to an F5, that type of stuff, without having admin accounts and integrations with everything? More like a central orchestrator to say, okay, go run this. You only have access to run something, right? Versus you have access to the CLI or you have access to the GUI or something like that, right? We can scale that back and control it centrally, audit it centrally, that type of stuff. Passwords and stuff like that, we no longer have to give out, right? The tools can store it encrypted. Agility, right? So we have workloads all over the place now, right? So the ability to light something up in one cloud provider, another cloud provider, that type of stuff, right? A lot of these declarative configs, blueprints, templates, that type of stuff can be reused, different cloud providers, obviously the on-prem stuff is still applicable. An F5 device in the cloud is the same as an on-prem device in terms of configuration, right? So it allows us to use single blueprints or single templates to configure wherever. Active documentation, right? So we're getting away from the traditional Visios, the traditional Word docs that try to explain, that are outdated the second that they get made, right? So we're going to see some of that today, the integration with Git, right? Where we have the project repository, the code is in there, the readmes are in there, that type of stuff, right? We know, okay, this guy made an update to this code, here's how it was before, it's all in one spot, right? So the documentation is living with the project, living with the set of devices you're configuring, depending on how that's laid out. But at the end of the day, you make a change, you can see the audit trail, you can see what happened before, you can see the old configs, that type of stuff allows you to, go back and do something or push something back that was there before. But at the end of the day, you're not creating ad hoc documents, you're not emailing stuff around, you're not dealing with, you still may be dealing with spreadsheets, hopefully not, but everything is in the repo, and there's one central spot to find it, right? So a lot of things to make things, more efficient, centrally control things, and make sure that, the devices can be configured in a common way. We're going to talk a lot about declarative configurations today, right? So not so much imperative stuff, like we're going to say, go run these commands on these devices. We're going to say, what do we actually want this application service or this configuration to look like, right? Here's the whole configuration type thing. If we need to change something, we make a modification, right? And the tools that are automating, actually applying that are smart enough to know, okay, this actually isn't there, I'm going to change it. Oh, this is already like that, I'm not changing it, right? The item potency piece. So who here is familiar with the term infrastructure as code, configuration as code? Who's actually done stuff around that? Yeah, so this has been kind of another buzzword for a while, right? It's kind of moved to configuration as code, it's more generic, right? We have network as code, infrastructure as code, right? I think infrastructure as code is a little bit more, widely used or adopted, but the main thing is we want to take the configurations we used to have in a text file, a notepad file, whatever, right? We want to start building them and put them in provision control, right? the code for the device. We're not going to create a conf file anymore and paste it in, or SSH it to the device, or something, CPU to the device, something like that, right? We're looking to define how we want it to be, and then we'll use the automation tools, like some of the stuff we're going to cover today, to actually orchestrate pushing that down to the device, updating the users, updating the admins, creating approval workflows, that type of stuff. I already covered point 2 there. The big thing, when you're making changes is if you make a mistake, it's still going to happen, right? Someone is going to improve it. Maybe they missed it, or they don't understand the implications, or they don't understand the architecture. You can easily roll back, right? If you have everything in source code manager, you can go back to the previous commit, right? Basically, the nice thing about the declarative nature is basically to say, it's going to know, okay, here's how it was, here's how it is now. You roll back, it's just going to basically dump it down and say, okay, here's what you want it to be, right? You're going to remove that error in the process, and you're going to have you back to your node working configuration, right? So, access control is a big thing we talked about. How are you giving access to devices, right? So we don't need to give everyone access to switches and routers and F5s and that type of stuff anymore, right? We can orchestrate configuring devices from Git, right? With some other plugins, that type of stuff, other orchestration tools. But at the end of the day, we can essentially control the credentials, right? Which is the big thing, right? We don't have to get stuff out. We can give lower levels of access to whichever tools that they can run what they need to do, but they can't actually touch the code, change the code, SSH to the device, those types of things, right? So we talked about the cutting and pasting. Obviously, that comes back to the chance of making errors, right? The chance that you're actually just dumping stuff into the device. There's not a lot of intelligence behind it, error checking, that type of stuff, right? How do you roll back when you're copying and pasting? Maybe you lost connection to the device. You could be screwed, right? So at the end of the day, we want to get away from that. We want to do things consistently. We want to store it somewhere where all this is audited and controlled at the same time. So we're going to talk more about application services configuration around the F5 side, right? Obviously, network's still a big portion of it. F5, there's a lot of networking portions of it. Today, we're going to look more at layer 4 to 7, right? So we mentioned this a little bit. Application services, it's called AS3, right? This is something that F5 has published, right? So basically exposing a REST endpoint from an API perspective, right? So obviously there's the iControl-LX API that already exists today. You can do your existing API calls, etc. The nice thing about this is more geared towards declaring how the application should look, right? Not so much configuring the big IP, right? It's more about, okay, you want to set up a VIP, you want to set up a couple nodes and tools, you want to apply security and certs and all this type of stuff to it. Well, now we're giving you a programmatic and declarative way to actually do that, right? So you can see there's a lot more ways to tie this in with other workflows. We're going to talk about some of that and show some of that, but this is fairly new from F5. There's some demos out there. There's some documentation out there. We've dug into it quite a bit and kind of seen what's possible, but it's still pretty early days. Not a lot of people have really touched it. It's still pretty new. It works well for our introduction to it and what we were using it for in terms of the demos, but this JavaScript runs on Node.js. It's just exposing another API endpoint, right? So it's an RPM installed with a big IP, so pretty easy to get on there, right? Pretty straightforward. We've automated in some of our demos. You can do it through the GUI however you want, but one of the advantages to this is, as we talked about F5 working anywhere, cloud, on-prem, any environment really, AS3 is the same way, right? A VE F5 is the same as a hardware F5. You can still install the package the same way, right? So it's no different than any F5 you're dealing with today on-prem. You go to a cloud provider, you light up a big IP, you install the AS3 RPM, same thing, right? You're exposing the endpoint. At that point, it's are you allowing the traffic to get to the F5, et cetera, right? It's more network security discussion at that point. And then we've already talked a lot about the declarative stuff, right? AS3 uses JSON definitions, right? So basically you're going to define how your app's going to look, the security around it, that type of stuff, all in JSON, and it's smart enough to basically look at the big IP and say, okay, you want this, I'm going to apply it. Obviously, if it's, if there's errors and stuff, then it's not going to, but smart enough to deconstruct that and build your application services. That's really what it's geared towards, right? It's not to configure the big IP, right? There's declarative APIs that will do that, right? Setting up IPs, route domains, that type of stuff. This is more geared towards defining an application service, right? Defining some security parameters around that. It's most focused on LTM right now, right? But the AFM, ASM stuff is there pretty close right now. So, but we'll show you some of the stuff today where it's at, and it's still pretty powerful. There's another piece to it. This is something that's kind of been developed off to the side, right? So webhooks, obviously they can call the API that exists today. There's actually a package, another RPM that you can install on the big IP that will listen for webhooks, right? So basically, it's a listener. You program it for where they're going to come. You make sure the traffic can come in. And at the end of the day, you're basically creating a workflow to say, okay, I have AS3 that knows how to talk to the F5 and knows how to write the declarative config. Where is the declarative config going to come from, right? In our case, it's GitHub, right? It could be any Git platform, right? It could be other things to orchestrate it. At the end of the day, this webhook server is just listening and waiting for a webhook coming from, in our case, GitHub, right? Commit messages are going to fire the webhook. The webhook's going to talk to the listener. Once the listener receives the call, it's going to call back out to the Git platform, and it's going to look for any service definitions in the JSON format, right? So, so it's actually writing the stuff to the big IP via AS3, but this is another module or another service running on the big IP. It's using a personal access token in our case, right? So we're able to say,
question.
Yeah. Do like AS3 model, we need to install that or like come with the AS3?
This is a separate module.
So here's the question for me.
Yeah, so he's saying, is this a separate module from AS3? So yes, they need to be installed separately. They're two separate RPMs, right? This is basically creating a server on the big IP, right?
And a separate partition.
Yeah, I should mention that actually. I'll cover that real quick. Cool. So yeah, the nice thing is we can give it to access to Git with less permissions, right? We can say, you have access to look at the repo, you have access to pull stuff down, and you can't write or anything of that sort, right? So all the writing is done through the workflows, right? Someone's going to do a commit, someone's going to merge it, or create a pull request, then merge it. At that point, it's going to get sent out, it's going to come and pull it down, right? So it doesn't have access, right? We don't need to open up a token that has tons of access to the repository of the project, right? So it's pretty slick in that respect. I just want to give you a quick overview of what this actually looks like in terms of the JSON piece, right? So as we talked about, it's very geared towards app services, right? So essentially we're doing configuration as code, defining our applications as code now, right? So you're going to be able to see the various different levels here, right? We're defining tenants, we're defining virtual addresses here, right? So your traditional VIPs, the pools, the monitors, and then the nodes at the end, right? So it's pretty straightforward, right? You don't really need to know a ton about JSON, right? There's a few examples to get you started. But this is essentially the service definition you're going to have in your Git repo, right? As I mentioned, it's layer 4 to 7 services, right? You're creating virtual IPs, right? You're creating, port access, you're creating nodes and pools, health checks, that type of stuff, right? Specific to the application. So declarative, right? So what we've been talking about already. Yeah.
AS3, when we use that, I've used it.
Yeah.
The testing system. And first of all, not everybody or every organization wants to create a separate partition, which I was able to create different virtual system. The problem is if you create a virtual server with AS3, you cannot go into GUI and modify that. So if in case you need to modify that, do you write a separate script for it to modify it? That's again a mental process.
Yeah, for sure. So the
is there a solution for that, right?
There's a couple points there. So just so everyone knows, when you do an application declaration through AS3, it just creates a new partition of the big IP, right? So if you create application 1, you're going to have one partition. That's how it is today. I expect that will change at some point potentially, because there's quite a bit of talk around that. I don't know. Maybe you know.
I mean, that's by design, and part of the reason if you're using AS3, so I'm Schumacher, by the way, I'm a finance controller. So that's by design. One of the reasons why that partition is specifically so that you don't get in situations where humans and robots are fighting. Because if you're using AS3, this now becomes the truth of that deployment, right? And if you have people going in and editing afterwards, you're breaking the whole point of having a declarative interface, right? So that's the rationale for that. The idea is that if you want to make a change, because it's declarative, if you want to make a change to it, you just change the declaration and push it again, right? So I don't see the permission requirement going away anytime soon, specifically because we want to make, there's two reasons. One is that if you have humans touching the box as well, we want to make sure that humans and robots don't fight. And the other reason is that if it's a purely robot-driven deployment, you shouldn't, the configuration becomes kind of relevant at that point, right? The F5 just becomes a widget that does what the declaration says. So I don't see that requirement going away. You do have the ability to create shared objects in common, but the partition mechanism is by design.
And the other thing that I found out, if you upgrade the iOS, or not iOS, the software, basically you lose all your any changes you made to AS3 without all the configuration. So, for example, if I'm creating all these partitions and I'm using a single repository or playbook that I use to Ansible Tower, put values in there and I'm pushing them, maybe 4 or 5 applications a week or something. And I've just upgraded my F5 to a new version. I've just lost everything. Do you do something like that?
Well, that's sort of the point of this, right? Because when you start treating your declaration as code, now, so that you have to know what is the source of truth for your infrastructure, right? And up until now, the source of truth has been the bigip.conf file on the big IP, right? But when you move that up a level and you start storing your code in Git, then the actual configuration of the box becomes irrelevant, right? And we're seeing, especially, less so with hardware, but especially with software-based solutions, where we're seeing people not even bother upgrading anymore. Because once you have all your configuration in Git, when it's just deploy a new box, new version, and push it again, it's way easier to try to upgrade your code.
Yeah, but that is if you are not upgrading code, when you have a policy in your company where you need to upgrade your code, you have to keep up to N-1 code level. So with this, it's like, say, a year we approximately create about 200 virtual servers for dev in different environments. And we upgrade our code, we lost everything, we have to go back and...
So where are you storing your declaration stuff?
So it would generally be this would be in a Bitbucket.
Okay.
So, but that would be the source file. Those are just variables that we won't be applying the exact IP addresses. It would be something that would have a template and Ansible Tower or something, and that template would be pushed to AS3 to the Ansible module for F5 AS3. And so those variables or those values that we send to the template, those are different for each version server.
Yeah, well, we actually have some of that covered in the demo already.
Yeah, but my point is...
Sorry, are you including persist true in your declaration when you push it? Because if you don't do persist true, it would actually say disk. Okay, so that still should, the config should survive the upgrade, but the AS3 module will be installed. Yeah, okay. But the configuration, if you do persist true in your declaration,
okay.
The config should survive the upgrade.
Okay.
Yeah, the big thing here is, we want to have the code in Git. Ideally, we're not having people touch the big IP directly anymore. We can go and make changes after the fact, but once those AS3 declarations are pushed down again, it's going to put it back, right, to the way it should be, right, based on the repo there. So yeah, that's what we're going to highlight today in the demos. Right, I covered most of this already, so I'm just going to jump past this. The big thing we want to highlight is the access control piece that we get with the Git, right? So the integration, the branch protection, right? Where people can't commit, they have to create their own branch, go through the approval workflow process before it gets merged in and actually applied to the big IP, right? So we have our approvers, our devs and stuff like that are contributing code, right? But you still have a approval work chain, a workflow, auditing, that type of stuff, right? So you can break it out with teams, etc. Right? So we're going to cover a little bit of that today in one of the demos. How many people have used Ansible here? Just quick show of hands. Cool. Yeah. So, why is Ansible good? Right? Easy configuration management tool, agentless. Right? You can go and use it for free. That type of stuff. Right? So. There's a lot of playbook examples out there. There's a lot of Git stuff out there. You can get started pretty quick. Right? You don't need to know any programming languages per se, right? We're using YAML here, right? So a lot of use cases. Basically, Ansible is a Swiss Army knife. You can do what you want with it, right? It's about how creative you're going to get, right? What you're actually looking to do. The nice thing is we can automate across different platforms, different vendors, different technologies with it, right? We're going to talk a little bit about Tower because we're using Tower in the demos for the orchestration piece, right? So the nice thing Tower brings is, aside from the interface, et cetera, is workflows, right? So we can start chaining playbooks together, right? We can start doing multiple things in a consistent workflow, right? We've talked about a bunch about passwords already. Where are we storing these credentials for Git, for switches, for routers, like that type of stuff, right? We don't need to worry about it anymore because now if we're using Tower to do the orchestration against the network devices, it's all encrypted in the credential store, right? You can't access it. You can get people to run a playbook. They can go query a device, potentially make changes, but they don't actually know the creds at the end of the day, right? Tower's controlling that. Role-based access control, we just covered that, right? Least privilege, depending on what you want. You could have, a lower tier that has only the ability to do some read access playbooks type thing, right? So, talked about YAML. The nice thing about Tower is heavily integrated with Git, right? So you have your project repository. All your stuff is pulled in from Git, and the orchestration takes place from there. We covered a couple of these with the API, et cetera. Ansible with F5, right? There's over 100 modules already, right? So F5's done quite a good job in terms of contributing that back and building stuff basically to do anything against the big IP, right? From security to networking, et cetera. If you haven't heard about it, they do have a super NetOps training, right? Free online. Go sign up for it. It's they're covering a lot of the DevOps, NetOps workflows now, right? So. The thing they're focusing on is, the entire application, right? So the network plumbing for it, the app control, traffic management, security, that type of stuff. They can offer all those stuff in an automated way, right? And with the workflow and the pipeline piece, right? It's pretty straightforward to integrate your tooling and stuff like that.
Yeah, let's cover some of this stuff. So just to level set on the OpenShift side, and then we'll kind of move into some demo-related stuff. In the microservices use case, we're using OpenShift as sort of the Kubernetes layer. If you haven't heard Docker, containers, Kubernetes enough times in the last 4 years, that must be a pretty pleasant rock that you're living under. I want in. Basically, the idea is it's pretty pervasive. It's everywhere, and so kind of what we're going to show in the final use case around the microservices piece is a pain point that we're all kind of experiencing on the network and security side of it. Is all of a sudden these container platforms become a black box that nobody's got any insight and visibility into, and so we're going to help bridge that gap a little bit, showcase a little bit of what F5 is doing in that space. To kind of be a first-class citizen, I guess, in terms of the containerization workflow. Just from a level set perspective, actually maybe this is easier. Who knows OpenShift or has heard of OpenShift? Okay, so enough. So I won't belabor it too much, but the idea being is a packaged version of Kubernetes developed by Red Hat. It's both a paid and a free offering depending on what kind of flavor you choose. The idea and mindset around it was to wrap enterprise-ready features around Kubernetes. And so to me, that kind of marries up really well with the F5 story around application delivery and security. And so that's kind of what we're highlighting those pieces. The only point that I want to bring up in conjunction with what Hark was saying is the idea being is this can run anywhere. So if we're talking about the cloud, we're talking about private, on-prem, it doesn't really matter. It's applicable kind of everywhere. And so we'll kind of see that in the use case as well. You want to talk about the...
We'll talk about it. All right, so we got to have a little plug for cloud here. We built this stuff on Packet, right? Bare metal cloud provider, right? So basically this is a host. On top of that, we've installed GNS3, right? Network simulator, I'm sure most people have heard of it, right? It's been around for a long time. Super powerful, but as you can see, we can do, lots of other things. We can run applications now, routers, switches, servers, whatever, right? We got OpenShift in here, we got a bunch of jump boxes, we have containers, everything, right? So it's a good place to centrally do the labs, right? So that's how we've architected it today. We tried to paint a little bit of a picture in terms of prod and DR, right? So we have a lot of the prod stuff on this side. The actual layout of the devices doesn't really dictate what they are, but in some of the use cases to kind of show, okay, we have a prod app, we're gonna fail over to DR, something like that sort of, right? So that's how we laid that out today. The nice thing about the bare metal is it gives you the option to bring up GNS in the way you want it, right? Versus a regular cloud, you may not have access to the hypervisor, that type of stuff, right? So pretty powerful. Happy to answer any questions you guys may have about that, but basically gone down that road for a lot of our labs just for the flexibility's sake.
I think the big story there is what we're simulating is an on-prem environment. So kind of what we wanted to do with this is kind of take away a little bit of the magic of the cloud in a way, just to kind of show that we can bring some of those features into the on-prem hub bridge and kind of get some of the elasticity that you get at cloud services in on-prem as well.
Yeah. Cool. So we're going to dive into the demos now here. As we mentioned, there's 4. We're going to start with an AS3, basically how we're going to set up AS3, right? We're going to use Tower to do the orchestration, but basically take the big IP, install the AS3 package, get things ready, that type of stuff. Just quickly talking about the workflow here, I mentioned this a little bit earlier, but obviously the orchestration tool here for us is going to be Tower, right? These things are going to be via commit, right? So all the stuff we're doing is on GitHub today, right? And the webhook we talked about already, basically the big IP is going to come back and fetch the stuff it needs, right? We've covered most of this, so I'm not really going to dig into it a little too much here. No. Okay, so we'll flip over to the demo here. All right. Cool. So I'm going to walk through this. I'm going to stop it kind of here and there, feel free to jump in and ask any questions. All right. So just kind of showing here that there's no AS3 package at this point today. Here's our repo, right? We have no webhooks configured. Basically, it's a plain install at this point in time. In Tower, as I was talking about earlier, we built a workflow, right? So multiple playbooks doing different tasks, right? We've chained them together, right? I'm going to quickly show the workflow here. Right, so you can see what we're doing here is we're going to actually install AS3 on the big IP, right? Next thing we're going to do is we're going to install that GitHub webhook server that we talked about earlier, the RPM, and then actually create the GitHub webhook via API call, right? All orchestrated with this Tower workflow, right? Broke it up into prod and DR. It just allows us to run different tasks against different site, right? Set different variables, right? So we can use the Ansible piece to run against either prod or DR without having to create separate playbooks, create separate roles. We're just populating variables, right? Right, so here we're installing the AS3 package, right? So we're taking the RPM, popping it over to the F5, that type of stuff, right? So pulling down the repo, right? So every time we run a job, we're going to sync the repo to make sure we have the latest code, right? Right. The big thing here is you have to first enable the AS3. You won't actually see it in the GUI or anything like that. You basically need to enable that in the F5 first, and then you can install it. And I'm going to do a little refresher. You can see under the IAP side where it's placed, right? Before we didn't have that, now we have a package management. right? So that's what that enable piece does. Actually copying the package over is pretty straightforward, right? The copying is basically the installation as well. There's no installation along with that. So you can see the workflow that's finished. It's going to move on to the next playbook, right? So GitHub web server, basically we're installing that RPM, pretty straightforward. It's going to start up the listener, right? There's a configuration portion here. I'm just going to flip back real quickly. We do have to configure the listener, right? Because it needs to know what's going to talk to it, right? We talked a little bit earlier about the personal access token, right? So the least privileged token, it'll allow it to pull stuff down from the repo, can't do anything else, right? So basically I just wanted to show you that here. I'm just going to put in that, or that would be hidden, right? It's stored as a variable in the credential store, no one can see it, right? For demo purposes, I'm showing it on the screen.
Kill you one.
What's that?
Did you kill that personal access token?
I am. But it doesn't have access to much, so. Anyways, guys, so screen cap. So at the end of the day, we're configuring. There's a couple parameters, again, in JSON that we're configuring against this, right? So we're just doing an API call basically into this to set where is it actually going to go call, right? That type of stuff, GitHub.com, etc. Setting the personal access token so it knows what to use to authenticate, etc. Right? That part's pretty quick. Right now we can see the different packages that are installed, right? So we got the GitHub web server and the app services piece, right? So just quickly back to the tower workflow, right? That was the second portion of it. Here we're going to jump into the actual GitHub webhook, right? This fires real quick. There's not much to do here. We're doing an API called github.com, right? Basically saying, create me a webhook, point it here, which is the AS3 through the firewall, that type of stuff, right? We've got all those nats in place already. We're just going to do a quick refresh here. Right now we can see the webhooks in place, right? There's credentials inside of that. They don't expose it here, right? But you can dive in and see there. Basically, when there's a commit to the repository now, that webhook's going to fire. Right, the GitHub webhook listener is gonna get that. It's gonna call back out and pull down any service definitions from the repo, right? So any JSON files that define virtual servers, nodes, that type of stuff, and it's gonna deploy that to the big IP, right? So we basically laid the foundation at this point, right? We can see some successful pushes, right? So basically, based on commit, we got a response back from the big IP, so we know that webhook chain is working properly, right? At the end of the day, we got nothing set up yet, right? We haven't defined any service definitions in our repository, so the big IP is pretty plain at this point in time, right? So what I wanted to highlight is we looked at this earlier in terms of the layout of the JSON, but highlighting actually deploying an app, right? Obviously, this is very much a demo, but we want to show how AS3 pulls in those declarative configurations and actually deploys it on the big IP. Right, so we have our beer definition, our beer app definition. All we're doing is we're creating it, we're going to commit it to the repository, and then we're going to go through the workflow we just talked about with the webhook, right, and AS3 right there. So, right, so just doing our git commit right now. We'll flip back here and verify that it's actually up in the repository now, right? One thing I wanted to highlight is we did a little bit of a Slack integration as well, so we can see when there's a commit, someone's going to get notified. In this case, we're just dumping it into a channel, right? But notifications, that type of stuff. As we move into some of the other demos, you're going to see when there's pull requests and stuff, right? We can click right from Slack and go right to GitHub, do our approvals, our reviews, all that stuff right through there, right? More of a notification, someone wants to update the app, right? Maybe this is an app-specific channel, that type of stuff, right? You can see the integration's simple, right? But you can see the power now. It allows us to jump right to it. It allows people to stay informed, right? That type of stuff, right? Someone makes a commit, someone can go look at it. Maybe they notice there's an error, that type of stuff, right? So, right, so I'm gonna just refresh the repo here and we'll be able to see now there's a deployment folder. Our app declaration is in here, right? And we should be able, now we're gonna go look at the big IP and see, as we talked about the partition earlier, right? And we now have a beer partition, right? Pretty cool. That JSON file, NAS3, is now deployed the beer app, right? What's it deployed? Whatever we declared it in the service definition, right? So the VIP, the pools, the nodes, the health checks, all those type of stuff. Pretty straightforward, right? See the health checks are up, the back end pool members are alive. Right? Let's verify that the app is actually available now, right? So we got a few fun Giphies here that are randomized. Right? One thing, there's not a lot of feedback in terms of there's log files and stuff like that, but specifically the GitHub webhook listener, it fires an issue into your repository to say, basically, what was the status of the deployment? Did it fail? Was it successful? You know what I mean? And obviously that stuff can come back in the Slack channel as well to say, okay, the deployment succeeded. Right? We turn that off because there's a lot of messages, but at the end of the day, you get some sort of indication what happened, right? If your app's not there, well, there's probably an error, right? And then you can go in and dig into the logs a little bit. It's more about the JSON declarations, right? If you missed a comma or something, that's a typical problem, right? Yes?
Yeah, so when and how do you determine if, once you do the commit, the webhook, do the deployment, so when and how do you determine if that configuration is absolutely going to work?
So in this case, we've skipped that step and we're committing directly to master. In the next demo, we're going to show branch protection, where you have to create a different branch. It goes through an approval workflow, that type of stuff. So it's not directly committed to the big IP. Someone has to look at it, someone has to review it, someone has to say okay. And once the pull request is merged to master, at that point it gets deployed. So
some of the, just to add to that, some of the areas where I see that this can now start to take is most of the Git platforms. GitHub certainly has this where you can start to inject status checks as requirements before branches can even be merged. So the vision there is as this starts to extend and mature, we start to put integrations in place at the check level. So you get some measure of automated checks before a human even has to hit the approve button, as an example. So they could be, they could be app checks. They could be, part of that status stuff is to go out and build something in an isolated environment, make sure it works, that sort of stuff. There's a lot of use cases that can start to come from that.
yeah, just the branch workflow is nice because we can have multiple approvers as well, right? So we can't just rely on one person say, oh, it's okay, he didn't even look at it, right? Maybe you need 2 people, right? That type of thing before it actually can be merged, right?
So on that branch, do you actually have to, do you have to go through the process of maybe pulling it onto the stage in the appliance to determine, it's good, and we're gonna merge the branch?
Yeah, there's a couple different ways to do that. Tim was mentioning maybe a lab environment or something like that, right? At the end of the day, the approval workflow is as good as who's reviewing it, that type of stuff, right? The nice thing we're going to highlight in one of the demos is the ability to roll back, right? So if it's a critical production environment, maybe you have a bunch of approvers, maybe you have a separate, pre-prod environment or something, you're going to deploy it there first, something like that, right?
Yeah, I see another use case starting to come from that as well, in that you start to get Ansible in front of this to start spinning up Jinja templates to actually template out the config before it even hits the Git repo. One of the areas we see for that is that could be a separate staging branch, as an example, that carries all the code with the right variables for the staging environment. Do the checks and balances in there. As long as everything succeeds, you return 0, go back to the next check, and kind of go through that. I think it needs a bit of time to kind of bake a little bit and kind of get some of those use cases fleshed out, but it's certainly where the vision starts to take it.
Yeah, more to see what's possible, right? Like that stuff can be done today, so it's going to get mature for sure, right? So we talked a bit about configuration as code. We just talked about branch protection. That's what this demo is going to cover. And then rolling back based on, an undesirable commit or something of that sort, right? So
I think just timing-wise too, we can run through this demo, run through this demo, take a quick break, come back and run through the last 2 demos, just from a pure logistics standpoint.
yeah, sounds good. All right, so this is our second use case here. Maximize that. Cool. All right. So we already have our app up from the original demo, right? The nodes are available, etc. Just gonna do a quick level set here. Right, so our app's there, it's declared. We haven't changed anything from what we just showed you. But now we're gonna create a secure workflow mechanism, right? The big thing here with Git, right, we're going to start to see now the pull requests and stuff coming in here, right? Not just the commit messages, right? We're not committing to master anymore. We've committed a separate, we've created another branch, we've created a pull request, right? We want to add something to the beer app, right? Right, so here, you know, the nice thing is we get to see what's changed right away, right? Or what's going to change, what's being proposed to change, right? So adding another node, right? So now we're gonna have 3 nodes in the pool versus 2, right? Very straightforward, but you can see it very easily on the screen, right? This is a 1 approver workflow, right? So we're just gonna, you know, basically say it's good, it looks good, there's only 1 line change, it's pretty easy to review, right? At that point now that we can do the merge, right? So we're gonna add in that pool member. AS3 is gonna be able to pull in that declaration now, and it's gonna change it based on what we've defined in there, right? Pull request merge, so our notification on the chat app side, right? We're gonna go back into the big IP. Obviously the app's still online, but we're looking at the nodes now, we have another node, right? So, you know, we can continue to see our great Giphies here, and probably just running through an extra few here just because they're funny, but right, so we now have another node, right? Pretty straightforward. We can add in more. The main thing is we use the Git approval workflow to say, okay, I'm now declaring I want this other node in, right, in the app, right? Pretty straightforward. But you can see everything sourced from Git. AS3 is actually delivering that to the big IP, right? Just a few more for good measure. Alright. So here we're, you know, that's the way it is today. Everything's in Git. I want to show quickly here what we were showing before, the listener, right? It's creating the issues, it's receiving stuff here, right? This is basically a pass-fail type of thing in this file. There's more granular logs that actually tell you what's going on.
That's AS3? That's the AS3?
Yeah, that's the AS3 log.
The AS3?
So this is the GitHub, the listener log.
And it's creating an issue?
Creates an issue in GitHub, yeah. Based on success or fail, but basically said it didn't deploy it or it did deploy it. It's not, here's the exact problem. Yeah. That'll be in the logs. It'll say this pool name is wrong, something like that, right? Okay. Incorrect pool name, incorrect node, that type of stuff, right? It's very, like if you extrapolate out the real logs, it'll show you that stuff, yeah. Right? So if it gets to the point where you should, you know, your pre-checks and stuff should take quick care of this type of stuff, right? Some mechanism to verify is the JSON correct, et cetera, right? So, right, we can see the success on the previous deployment here. We're going to come here as a reverting back to the previous config, right? We had our node working config with our 2 nodes. We want to now go back to that, right? We don't need that other node, you know, it's a demo, right? The big thing is, you know, we're good with 2, we'll go back to 2. This highlights the Git workflow because now we can control everything through the repository, through the approval workflows, right? So very straightforward. Another pull request, we're going to say, okay, I want to remove that node now, right? As you can see the diff, right? Changing back to 2. Right? Proving that similar to before, but now we're going back to the previous command, right? Merging it with master, right? Very straightforward there. We have our Slack notification so everyone knows what's going on, right? We come back to the big IP, and we're going to see now we're down to 2 nodes again, right? Everything's controlled through Git. We have our approval workflow there, right? So we can control who has access to what, who can commit, right? The main thing here is we have approvers, right? As you can see, the person merging it, and you have your contributors, someone saying, oh, here's my pull request, I want to do this, right? But you don't have to approve it, right? And that's what we're going to cover off next. The fact that there's a pull request and to change something in the declarative JSON, but maybe it's not approved, maybe it's not correct, maybe someone did something unintentionally or maliciously, who knows, right? There's a workflow there and everyone's notified because, you know, they're in the channel ideally, right? So here we can see a little bit of, you know, hackery from Tim. He wants to change it to a wine app, right? So maybe he doesn't like beer, you know, we're going to change everything to wine and try to redeploy that way, right?
I think there's just, while you're running through there, I think there's two stories there. One is sort of the separation of duties from an actor standpoint, right? So me as the one that wants to make the changes, I'm kind of free to kind of make whatever changes I want, but it still leaves it up to the reviewers to kind of do what they need to do. And so from a Git standpoint, that would come down to like, code owners, maybe you're going to restrict it down to specific user bases that have access to change particular parts of the repo. The real win for me there as an actor standpoint is if I'm on the hook to go deploy the next iteration of the app, whatever that app is, and I need to make the changes, I've got kind of all of that stuff in one repository. I don't have to go to that, the change request, wait 2 weeks for a load balancer to get built, and then come back to me and hopefully it was done right, and then go try my app deploy, only realize that the IP address was wrong in a pool member, and then it's another 2-week cycle, or whatever that case is. We've all been through those kind of back and forth, push and pull kind of exercises. So to me, the win is that sort of concept of having all of that self-contained in one repository. Everything's declared there, right up to the network level to get the application delivery, right down to the app itself.
And now we have the entire audit trail here, right? Yeah, sure.
I saw in the language there's a keyword action, and it's deploy right now.
Yeah.
But is there a destroy or what other
Yeah,
actions?
so there's remove, redeploy, that type of stuff. A handful of options there. If you remove the service definition, like say we took away that beer.json file, it would remove it from the big IP. So that's another way of doing it.
How does it know just to remove that one declaration and not everything? Is it
Basically, it looks at any JSON declarations in the repo, right?
Oh, okay.
And if you take one away, it says, well, you're declaring I should have only these configs now, and removes it, right?
Does that mean that I have one repo to control VM5 for everything, or is there like a scope you can specify for certain declarations?
Yeah, so in the GitHub, in the webhook server, you can specify a repo. The way we've done it is we've created different repos for different areas. So like a DR repo, a prod repo, that type of stuff, right? Just to kind of delineate that and make it a little more simple. If we're going to set something up for DR, another way you can look at it is if we want to variabilize it, we can do it that way too, but
How does it know the scope when you find it in different repos? How does it know that this is DR stuff when I remove these definitions of JSON things? Remove all DR stuff.
So we're covering that a little bit in the demo. What we're actually doing for the DR side is we're building the service definitions when we fail over.
So I think what you're getting at is the repo servicing both DR and prod,
Yeah.
but one repo, which isn't the case here. As far as I know, we can't split it out that way yet, so we don't have a lot of the scoping mechanisms that you're looking for. As far as I'm aware, Adam might be able to tell a little bit better whether or not that.
I'm trying to imagine it on a really big enterprise level where I have lots of business units sharing a single device, they have their own repo that they want to work on, and
Yeah, so there's really 3 tiers that you can deal with in a declaration. So the declaration itself, so the top level, declaration can contain tenants, the tenants can contain applications. An application can contain one or more virtual servers. So there's 2 ways of breaking this down. So you can have multiple declarations against the same BIP. And then if you delete, so normally it's a HTTP operation, right? So here we do delete with a declaration, like you get a link, endpoint to that declaration when it's posted. So you can delete just that declaration and leave the rest of it attack. You could also manage it all through a declaration and have each tenant in its own section of that declaration. So you can separate things that way, and that's when tenants go into their own partitions. So there are a couple ways of breaking that down, right? So it doesn't have to be all or nothing. And this is where that whole, you have nothing but what your data model is and how you're going to translate a manifest or description into that declaration. And it could be, you could have a declaration that you just store in Git, like you're doing here for a particular app, or you could have it described somewhere else that's synthesized by your automation into a large declaration, right? There's more than one way of saying that gap.
Yeah, and I see it too. There's likely some areas to shore some of that up with something in the middle. So rather than a direct webhook where you can get all the way to AS3, having something in the middle. So your webhook's calling something intermediary, call it Ansible Tower or something that is able to do some of the filtering as well. So, don't care about this branch, I care about this branch, I care if this person needs that, that sort of stuff that you might want to get some more filtering capabilities at the webhook level. To me, the webhook save too is a little bit of the cutting out the orchestration layer. Like you don't need something else to go deliver the config.
Yeah. Cool. So I'm just showing the notification on Slack there at the end, right? So really just a protected branch approval workflow there, right? A couple different things. Applying a config, right? Changing the service definition, having AS3 pull that down to the big IP, reverting. And the last one we did was, not even committing it because we didn't want to, right? We just close the pull request, it never gets committed. The audit trail's there, right? So a lot of different things you can do with it. But that just shows you can use the Git as the central point of control to store the code, to approve it, right? And then we have the other tools in the workflow to actually deliver that declarative code to the big IP. So yeah, it's the second demo, wrapping that up. I think we'll take a quick break here.